A thin rod is hinged at point O and is in a unstable equilibrium. Okay, it means that initially it is at point 1. Okay, now since it is at a position 1, since it is in the position 1, it will be in the equilibrium state, but it will be in unstable equilibrium. It means that the potential energy will be maximum at this point. Okay, it falls under the action of the gravity due to slight disturbance and makes an angle 60 degree, 90 degree and 180 degree with the vertical positions. If omega 2, omega 3 and omega 4 are the angular velocities at this position, we have to find out the relationship between them. Let me draw a zoomed in diagram over here. Okay, of the same part. Let this be the reference line O, where the potential energy over here is minimum. Okay, let this be the reference line where the potential energy over here is equal to 0. Okay, initially when the body was at this position, at the first position, it only contained the potential energy. Okay, and the height over here will be equal to L by 2. The height over here of the center of mass will be equal to L by 2. So let me first write down the total energy at point 1, which will be equal to kinetic energy plus the potential energy. Now since it is in equilibrium, the kinetic energy will be equal to 0, potential energy will be equal to mgl divided by 2. Let this be equation number 1, we will use this later. Now when the rod arrives at a certain other position, let us say it makes an angle theta with a vertical. Okay, now the center of now over here, if I draw, if this is the length of the rod, okay, this height will be equal to L cos theta. Okay, this height will be equal to L cos theta. So the center of mass will be at a height of L by 2 cos theta. Okay, center of mass will be half of that height, which will be equal to L by 2 cos theta. So over here the total energy at, let us say, the second point, the total energy at point 2 will again be equal to kinetic energy plus potential energy at point 2. Kinetic energy, let it be equal to half I omega 2 square, I do not know the value, plus the potential energy. Potential energy over here will be equal to mg into L by 2 cos theta. Okay, this is a general equation. This will be applicable for all the values of theta over here. Okay, all the values of theta over here. Let this be equation number 2. We will use this again and again for the point 3 and point 4 also. So now over here, total energy at point 1 will be equal to total energy at point 2. That is, it is equal to mgl divided by 2 will be equal to total energy at point 2 will be equal to half ml square divided by 3. Why ml square divided by 3? Because the body is rotating about point 2, that is about one of its end. Okay, divided by 3 into omega 2 square plus mg. In the second case, cos theta is equal to cos 60, which is equal to half. So when I substitute this value, it will be equal to, I will shift this term on the left hand side of the equation. So basically it will be equal to mgl divided by 4 is equal to half ml square divided by 3. So over here m and m will get cancelled out, L and L will get cancelled out, 2, this will become 2. So basically it will be equal to, basically the omega square, this will be equal to omega 2 square, sorry. Okay, so omega 2 square will be equal to root 3, okay, root 3 divided by 2, root 3 divided by 2 g into L. Okay, in all these equations root gl will remain constant, so I will write this as root 3 by 2 into constant k. Okay, let this be equation number 3. Okay, let me substitute for different values, let me substitute for different positions. Now I have got the position at 2. Okay, let me find out for at 3. Okay, let me find the angular velocity for position 3. At position 3 over here, the theta is equal to 90 degree, theta over here is equal to 90 degree, so cos 90 will be equal to 0. So I will use this same equation which I used to find out the total energy at point 2. So instead of total energy at point 2, I will write this as total energy at point 3 will be equal to half ml square divided by 3 into omega 3 square plus mgl cos theta, cos 90 will be equal to 0. So plus it will be equal to 0. Now total energy at point 1 will be equal to total energy at point 3. Total energy at point 1 will be equal to mgl divided by 2, and at point 3 it is equal to half ml square divided by 3 into omega 3 square. Okay, so basically m and m will get cancelled out, L and L will get cancelled out, 2 and 2 will get cancelled out. Omega 3 will be equal to, omega 3 square will be equal to 3g divided by L. So basically it will be equal to omega 3 will be equal to root 3 g by L, root of g by L I have taken it as constant. Let this be equation number 4. Okay, let this be equation number 4. Now we have to find out the omega 4. We will use the same formula. theta over here is equal to 180 degree. 180 degree, it means minus 1. So basically total energy at point 3 will be equal to half I over here is equal to ml square divided by 3 into omega 4 square plus over here it will be equal to mgl by 2 into minus 1 into minus 1. Now this is equal to total energy at point 1. So total energy, so it will be equal to half ml square divided by 3 into omega 4 square plus it will be equal to or minus mgl by 2 minus mgl by 2 is equal to mgl by 2. So basically mgl by 2 when it shifts on the right hand side, it will be equal to ml square divided by 6 into omega 4 square will be equal to mgl. So basically m and m will get cancelled out, l and l will get cancelled out. So omega 4 over here will be equal to omega 4 square will be equal to root of, or it will be equal to omega 4 square will be equal to 6 times g by l. So omega 4 is equal to root 6 into constant k. Let this be equation number 5. Okay, let this be equation number 5. Let us find out the relationship between omega 2, omega 3 and omega 4. Omega 2 over here is equal to root 3 by 2 k. Okay, so basically I can say that the relationship between omega 2 and omega 3 is that omega 3 will be equal to root 2 times omega 2. Okay, omega 3 will be equal to root 2 times omega 2 and omega 4 is equal to root 2 times omega 3. So basically omega 4 will be equal to 2 times omega 2. Okay, omega 4 will be equal to 2 times omega 2. I am just equating all this part. Okay, so let us check the options, which of the options are correct. If I check the option number B, omega 4 will be equal to 2 times omega 2 is a correct answer, which is option number B.